Welcome back, everybody, to another deep dive. This time, we're going to be talking about endocrine-disrupting chemicals.
EDCs.
EDCs, right. You gave us a research statement from the Endocrine Society.
Yeah.
And, they're like the hormone people, right? So this is a big deal. This is their stance on EDCs. So we're going to break down, the key takeaways from this paper, like how EDCs work, why they're even something to be concerned about, and then how do we actually figure out what the risks are. It's complicated, but luckily I have an expert here who's going to make everything super clear.
Yeah, it's a really crucial topic, for sure. Well, first of all, the Endocrine Society, they actually define an EDC as anything that interferes with hormone action.
Mm-hmm.
But interestingly enough, they're very clear about the fact that just because something can interfere with hormone action, it doesn't necessarily mean that it's going to cause you harm.
Oh.
Yeah, so the potential for something to be harmful really depends on a whole bunch of factors, like the dose, how long you're exposed to something, and also when in your life you're exposed.
Yeah.
So, there are certain times, like development, where we might be a lot more sensitive.
Right. So even if something can mess with your hormones, it's not a guaranteed health disaster.
Right.
So then that makes it even more important to figure out like which ones we really need to be careful about.
Yeah, exactly. And to understand why EDCs can be so powerful, I think it's good to kind of step back and remember how hormones work.
Okay.
So hormones, the way they act is they bind to receptors. Think about it like a light switch.
Okay.
So the hormone is like the thing that flips the switch, and the receptor is the switch. And then when the hormone binds to the receptor, that turns on or off some process in the body.
Okay.
So EDCs can come in and they can either mess with that switch itself, the receptor, or they could pretend to be the hormone, and flip the switch.
Oh, right.
And that's what can cause problems because hormone systems, they're so finely tuned. So even these small disruptions can throw things out of balance.
Right.
And that's why, this whole idea of like a safe dose for an EDC, it can be kind of misleading.
So wait, are you saying like there's no safe dose when it comes to these chemicals?
Well, it's not that simple.
Okay.
Because one of the tricky things with EDCs is that their effects don't always follow a straight line.
Okay.
It's not always like more dose equals more effect.
Yeah.
Sometimes you can actually have a smaller dose have a bigger impact than a larger dose.
Yeah.
And the Endocrine Society really emphasizes this point.
So it's not just the amount, it's like a bunch of other factors too.
Right. And we call this a non-monotonic dose response.
Okay, can you give us like an example of what that would look like? Because that kind of seems counterintuitive. Like, how could a smaller amount be worse?
Yeah, so a good example of this is bisphenol A, BPA. You've probably heard of that one.
Yeah.
So there are studies that have shown that BPA can actually have more of an effect on prostate cell growth at lower doses than at higher doses.
Oh, wow.
And this is actually, they cite specific studies in the statement that show this.
So even if a dose is low, we can't just assume that it's harmless.
Right.
Especially with this stuff.
Exactly.
And that really changes how you think about these chemicals then.
It does. And it also highlights, another really critical factor that we have to consider, and that's developmental sensitivity. So exposure to EDCs during, key developmental periods, like when you're a fetus or you're going through puberty, the effects can be a lot more long-lasting and sometimes irreversible. And this can happen even at low doses.
Yeah, so it's like if you mess up the foundation of a building while it's being built, then the problems might not show up until years later.
Yeah, exactly. That's a great analogy. And they actually talk about this in the paper, too. They give the example of diethylstilbestrol, DES. It was a drug that they used to give to pregnant women to try to prevent miscarriages.
Oh, wow.
But then years later, they found that it had all these serious consequences for the reproductive health of their daughters.
Oh, no.
And so this really makes you wonder, like, are we missing some of the long-term impacts of EDCs, especially during those vulnerable stages of development?
Yeah, because we wouldn't know for years.
Right.
That's kind of scary.
Yeah, it's a little it's a little unsettling for sure.
So the paper highlights some specific examples, like of some EDCs.
Yeah.
So I guess let's dive into a couple of those. First up, PCBs. Tell us a little bit about them.
Yeah, so PCBs, polychlorinated biphenyls, they're a really good example of just how complex this issue can be. They were widely used in all sorts of different industrial applications, but they were banned decades ago.
So they're gone now, right?
Yeah.
Problem solved.
You would think so, but not quite. PCBs are very persistent in the environment. So that means that they don't really down very easily, and they can actually build up in our bodies over time.
Oh.
Um, and what the paper points out is that PCBs can actually lower thyroid hormone levels without even causing any obvious damage to the thyroid gland itself.
What?
Yeah.
So they're still out there, even though they were banned years ago.
Yeah. It's crazy, right?
That's not possible.
Well, because they don't break down easily, so they can linger in the environment for a long time, and then we can be exposed to them, and they can accumulate in our bodies. And it brings up an important point about our current testing methods and whether our testing methods are really catching everything.
So you're saying we might be underestimating the risks because of how we're testing for them.
Potentially, yeah. Because, I mean, if you think about it, like with the PCBs,
Yeah.
the EPA's Endocrine Disruptor Screening Program,
Yeah.
EDSP,
Yeah.
it looks at changes in the thyroid gland itself as the main sign of a problem. But PCBs can disrupt thyroid hormones in other parts of the body, like the brain, without actually causing any noticeable changes to the gland itself.
Oh, so we're looking in the wrong place.
Yeah, potentially.
Oh, that's kind of alarming. What about phthalates? What are those, and what should we be worried about with those?
Okay, so phthalates, they're mainly used to make plastics more flexible. So you'll find them in a ton of different products. Food packaging, toys, personal care products. They're pretty ubiquitous.
Okay.
And the concerning thing about phthalates is that they can disrupt male reproductive development,
Oh.
especially during fetal development.
So that's exposure in the womb could have, like, lasting consequences.
Exactly.
Wow.
And what's even more worrying is that the effects might not even show up on, like, your standard androgen tests.
So even if the test comes back and it says it's normal, it doesn't necessarily mean everything is okay.
Right.
That's concerning.
Yeah, it really emphasizes how we need to be, a lot more vigilant. And, luckily the Endocrine Society, they have a whole bunch of recommendations for how we can actually improve, our research and testing for EDCs.
Okay, so what are some of their, like, key suggestions? What are they saying?
So they're calling for more sensitive tests. They can actually pick up on those subtle effects at those low doses. They also want to see developmental exposure included in the testing.
Okay.
And they want researchers to really consider that those dose-response relationships, they're not always linear.
Right.
Like we talked about.
So we gotta look at it in a different way.
Yeah.
It's a pretty big shift in how we think about it.
It is.
Okay, so this is really fascinating, but I'm kind of curious. The Endocrine Society also mentioned dioxin-like compounds in this paper.
Yeah.
What are those, and what are their potential health effects?
Okay, so dioxin-like compounds, they're actually a group of highly toxic chemicals that can cause a whole range of health problems. And they're mostly byproducts of industrial processes, but they can also be released into the environment through things like forest fires, things like that. And they're just like PCBs in the sense that they're persistent, so they stick around in the environment for a long time.
Okay.
And they can bioaccumulate, which means they build up in the food chain.
Oh, so even if we're not directly exposed, we could still be getting them through our food.
Exactly, yeah. Dioxins are known to accumulate in the fatty tissues of animals.
Oh.
So eating things like meat, dairy products, and fish can be a pathway for exposure.
It seems like it's kind of like a complex web.
It is.
That we're still figuring out how all this works.
It's a big puzzle for sure.
Yeah. Well, I think we'll probably need to save the rest of this discussion on dioxins and testing methods for part 2.
Yeah, sounds good.
We'll be right back.
Yeah, there's definitely a lot more to unpack when it comes to dioxins and just how we assess the risks of EDCs in general. It's not just about developing new tests. It's also about looking at the data we already have through a different lens and really thinking about how, how those regulatory agencies, how they weigh the evidence.
Right.
That needs to change to really consider these endocrine principles that we've been talking about.
So we can't just rely on, like, the old ways of thinking about toxicity.
Right.
Where it's just like, oh, a higher dose always means a greater risk.
Exactly, yeah.
Yeah.
We need to factor in what we know about hormone action, about how sensitive we are during development, and that possibility that those low doses can really have a big impact.
Right.
So our whole risk assessment process really needs to catch up to the science.
It seems like we need, like, a much more complete picture than we're getting right now.
Absolutely. And the Endocrine Society, Their recommendations are really a call to action for everyone involved, for researchers, for regulators, policymakers,
Yeah.
to really uh, take a more comprehensive and scientifically sound approach to
Mm.
protecting public health from the potential harm of EDCs.
Yeah, it's a lot, and it's kind of overwhelming, I gotta say.
Yeah.
It feels like they're everywhere, and we're only just starting to understand how much they could be affecting us.
It's understandable to feel that way.
Yeah.
They are pervasive in our environment, but I think awareness is really the first step towards taking action.
Okay.
And so by understanding, how they work and the risks they pose, we can start making informed decisions to minimize our exposure and protect our health.
So, I mean, what can we do, like as individuals? I mean, can we avoid them completely?
It would be pretty difficult to avoid them completely,
Right.
but there are definitely steps we can take to reduce our exposure. So, choosing BPA-free products, opting for natural cleaning and personal care products, um, trying to cut back on our reliance on plastics. Those are all really great places to start.
So it's like being more aware of what you're buying, reading labels,
Exactly.
making sure, like supporting maybe like stricter regulations on EDCs, those kinds of things can actually help.
Absolutely, yeah. And we can also support research efforts that are aimed at better understanding these risks and addressing them.
Hmm.
The more we learn about these chemicals, the better equipped we'll be to protect ourselves and future generations.
Right. So back to those dioxin-like compounds for a minute.
Yeah.
Can you tell us a little bit more about how they actually get into the environment and what kinds of health problems they can cause?
Sure. As I mentioned before, they're mainly byproducts of industrial processes, but, things like forest fires can also release them into the environment. And the thing about dioxins, just like PCBs, is that they stick around for a long time.
Right.
They're persistent, and they can build up in the food chain.
So again, even if we're not like directly exposed to these chemicals, we could be ingesting them through food.
Exactly, yeah. Dioxins tend to accumulate in the fatty tissues of animals, so eating things like meat, dairy products, and fish can be a way that we get exposed.
Okay.
And this is just one example of, how crucial it is to really understand how these EDCs move through the environment
Yeah.
and the different ways that we might come into contact with them.
It really does seem like scientists are still like trying to put all the pieces together of
Yeah.
this really complex puzzle of how EDCs impact our health and the environment.
It's definitely it's a multidisciplinary effort, that's for sure. We
Yeah.
need endocrinologists, we need toxicologists, environmental scientists, policymakers, all working together to tackle this issue. But I don't think the complexity should stop us from taking action.
Right.
We need to keep pushing for more research, tighter regulations, and just greater awareness of the potential risks of EDCs.
It seems like the Endocrine Society's statement really drives home this point that EDCs are a serious issue
Yeah.
with potentially widespread consequences for human health. And it feels like a wake-up call to be more like proactive, I guess, and cautious about how we manage these chemicals.
Absolutely. It's a call to action for all of us,
Yeah.
scientists, regulators, policymakers, and individuals.
Right.
We need to all work together to protect ourselves and future generations from the potential harm that these EDCs can cause.
It's really fascinating how like all of this research is challenging what we thought we knew about toxicology and risk assessment. Like we're learning that the old adage, the dose makes the poison,
Right.
doesn't always apply when it comes to EDCs.
It's a real paradigm shift. We're seeing that these low doses can have really substantial effects, and that the timing of exposure, especially during development, is absolutely crucial.
Yeah. It seems like we need to rethink how we approach chemical safety and regulation altogether.
Absolutely. We need to take a more precautionary approach, one that prioritizes the protection of vulnerable populations, and that takes into account the long-term impacts of EDC exposure. And the Endocrine Society's statement really is, it's a call for a more holistic and scientifically sound approach to managing these chemicals.
It's about recognizing that our endocrine systems are like intricately connected to our overall health and well-being, and protecting them from disruption is really important.
Absolutely.
Mm-hmm.
The health of our hormones is intrinsically linked to the health of our planet.
Right.
And so by taking steps to minimize our exposure to EDCs, we're not only protecting ourselves, but we're also contributing to a healthier and more sustainable future for all.
It seems like we need to be more mindful, not just of like the products that we're using, but the foods that we're eating and the environments that we live in.
It's about empowering ourselves with knowledge, advocating for change, and demanding a higher standard of protection from the potential harms of EDCs. We have a collective responsibility to safeguard our hormonal health and ensure a brighter and healthier future for everyone.
It feels like we've just like scratched the surface of this whole
Ugh.
EDC thing.
It's true, the world of EDCs is so complex,
Right.
and there's still a lot we don't know. But the good news is that research is, moving forward pretty rapidly.
Yeah, and what's really interesting is how this research is like challenging, like you said.
Right.
Everything we thought we knew about like toxicology and how we assess risk.
Right. That old saying, the dose makes the poison, it just doesn't always apply.
Yeah.
When we're talking about EDCs, we're finding those very low doses can have significant effects.
Yeah.
And the timing, that timing of exposure, especially during development, that's huge.
Yeah. It almost feels like we need like a whole new approach then to
Yeah.
chemical safety and regulation.
Absolutely. We need a much more precautionary approach, one that really makes protecting vulnerable populations like uh, pregnant women and children a priority,
Hmm.
and one that really considers those long-term impacts
Right.
of EDC exposure.
Yeah. And the Endocrine Society, like, they're really serious about this in their statement, right? They're saying we got to take a more comprehensive and scientifically rigorous approach to, like, managing these chemicals.
Absolutely. We got to weave those endocrine
Yeah.
principles into our research, into our testing, into our regulations.
Right into everything.
Yeah, to make sure we're really doing everything we can to protect human health.
This has been such an eye-opening deep dive. It's amazing to see the way, like, these subtle ways that EDCs can impact our health.
It really is. And it's a topic that deserves our attention.
For sure.
And I think, by staying informed, by making those conscious choices
Yeah.
and advocating for change, we can really work towards a healthier, more sustainable future.
Yeah, not just for ourselves, but for like future generations.
Exactly.
Well, I want to thank you for like walking us through all this. I know it's complicated stuff, but I mean, your insights have been super valuable.
Oh, it's been my pleasure. I really believe that knowledge is power, and I hope this deep dive has kind of inspired you to go learn more about EDCs and take steps to minimize your own exposure.
Yeah, we'll definitely link to the Endocrine Society statement in the show notes.
Great idea.
So if anyone wants to learn more, you can head over there. But for now, I think that's going to wrap things up for us.
Okay.
Thanks for joining us, everybody, on this deep dive into the world of endocrine-disrupting chemicals. Until next time, stay curious, stay informed, and stay healthy.